Hello everyone. I'm Sangeeta Jha and I'm the DSC lead of DSC IGDTUW. I would like to welcome you all to our session, Demystifying Cloud. We could wait for 2 more minutes for everyone to join and then we will start. So, without wasting more of your time, I would like to start with the session, and I would like to welcome our speaker, Aman Sharma, CTO and co founder at Twimbit. He's one of the top 10 most inspiring CTO 2019 and also founder and lead at mobile.webdev. He's also founder of Atlancy and Key Events and former recommender system engineer at Upsell.ai Athens. So I welcome you to the session as a speaker, and so platform is all yours.
Thank you so much, Sangeeta, and thanks for audience today on joining for this session. So actually, we were thinking of what we can do in this Hacktoberfest thing that is going on, and I'm not like a kind of a big fan of these seasons or everything going on, but it's just kind of gets the all the mood things going. And you guys might be already working in some projects. Most of you, I'm informed, are college students, and you probably are already working in some Python projects which involves Jupyter notebooks or tech like that, which runs fine totally on local system. But when you go for an internship, you go for a job opportunity, they say, do you know any cloud technology? Do you know AWS? Do you know Google Cloud Platform? Or just for like people who are even studying cloud and everything, I've seen that they are mostly doing it for the sake of swags, and there is no bad thing about that. But still, today's session is most about like when I first heard about cloud, what question arised in my mind and how I can make it clear uh, in your mind also. So as Sangeeta already explained, I am a founder and CTO at Twimbit. Twimbit is a research company, and we use a lot of technologies, heavy lifting technologies, which are based on cloud. And it has been very important for our team members and especially me to understand the whole workflow of cloud and how things should be done in order to plan the whole architecture. So I'll be trying to be as simple as possible, as explainer as possible, uh like to get all these things going. Hi, thanks for joining the session, and I'll try to be as simplified as possible. With this, I also lead a open source community named as Mobile Web Dev, which is focused on mobile web technologies, but we do some other kind of events also. So make sure to check out Mobile Web Dev also. We recently did a crash course on, which is totally free by the way, on web hosting and cloud. So this is a week long crash course, and we have all the material, slides, everything that I have used in this presentation also. So that would be very helpful if you want to get from 0 to 100 in terms of cloud. So, and also I work with AMP and OSI, and I haven't mentioned any credentials for cloud, but I have been practicing cloud for a very long time. So, the point that I firstly, when I heard about cloud, I mean, like, what's actually going on? Things, many calculations going in mind. In my college days, I've seen like cloud was a luxury for people to add it in their resume, like okay, they know Google Cloud or they know AWS Cloud. But for the beginners, especially me, it was like, what the hell this actually is like. I mean, wasn't the hosting enough? And now what this thing cloud is, and I have to learn it. And then in your college curriculum also, you're learning cloud computing. But we are going to kind of talk about some serious business, like this small Chinese guy who is trying to think, okay, cloud computing is some kind of serious business. And by the way, meme alerts, I have been added, like kind of adding and experimenting a lot with memes. So bear with me, even if you don't like them a lot. And if you like them, make sure to add in the comments so that it keeps my engagement level also high. And we'll do a quick check after just showing this agenda of what kind of audience level I already have, so that I don't explain the simple or basic things, but actually something that would help you learn things. So cloud is a very serious things, and that's what we are going to uh, kind of discuss. Oh my God, see, this is what happens when I don't plan my animations right, and now this animation is placed before that. But let's do this quick fix on the go. All right, cloud computing animation is gone and agenda is on. So we'll understand what is hosting and what are its various types. So basically, hosting is the first level of cloud, like the main evident fact of using cloud is to host something, and we'll understand what hosting is and what are the different types of hosting. Then we'll learn about some important cloud things. I am keeping everything in surprise mode, not to tell or reveal everything in just one go. We'll call them cloud things, and I'll tell you about all these things that you need to know in order to get things going. Then we'll talk about methods of control. This is also a mystery. What are the various popular cloud platforms? We'll do a little bit of playing around the cloud to see how different things works. Even if you don't have a credit card or something, I'll on my own expense go on cloud, spin off some things, and show you how things are done. And then the final question, what you should do next, because this half an hour or 1 hour session is not enough for you to learn everything in cloud. So this is basically mythbusters, which could also be a fancy way of calling this event, but let's keep it to demystifying cloud, and I'll try to be as simple as possible. And I'll also tell you what are the things that you should learn next in order to brag about cloud skills in your resume whenever you're going next. And if you think possibly there is a friend of yours or a classmate of yours that who also wanted to know about all these facts, and he can also benefit from this, so I'll be keeping a little bit of slow pace till you share the link and let him come. I'm not aware about how many of you are watching right now, but let's spread this knowledge, gyan ka sagar, to everyone, and let's everybody join and enjoy the things that I'm going to teach, not teach, but kind of demystify today. So, oh, this animation came back. Now let's move to another meme. So, basically, the problem with cloud computing that I felt was that no one actually understand what is cloud. And I was just thinking of this thing yesterday when I was creating my slides. I mean, there could have been million of things, million of different names that person could name it. It could be ocean. I mean, Microsoft is now dipping their servers in ocean. And it could be farms. Why they named it cloud? And nobody knows that. But we'll understand like what cloud basically is. So let's get started. The first essential thing about cloud is web hosting. Primarily, for whatever thing you will use cloud for, there will be an essential element of hosting taking place. Now let me explain you what hosting is. Let's imagine that you are working on a project, and it's working fine on localhost. Now you want this project to be viewed by everyone in the world, and everybody should be able to easily go through the platform without any hiccups and everything. So that is the thing that is called hosting. You are putting your application to some other machine. It's like your same laptop, but it's hosted somewhere. I mean, like, you're putting the application code somewhere so that it's easy for anyone at any time to reach to your application without any problems. And your basically, this machine that we are talking about is called server, because it's serving your application. That is why they are called servers. And this is the most essential part of web hosting. Now this is very generalized. Like, people started things with hosting their normal website, normal HTML pages. Then came the era of server side languages like PHP, .NET, Java, and they were hosting these application on servers. And now it is again coming back to Jamstack. I don't know if some of you guys do Jamstack or not, but it's a good, cool technology to use. So that is also utilizing the power of cloud to host your code somewhere. And like, now with increasing internet speed, it's also on the servers or the cloud capabilities or the hosting capabilities to serve your application in a right manner. So this is a general way of understanding of what web hosting is. So basically, web hosting is the host, atithi, and what do you say in Hindi? I mean, like, you got the term, right? So anything that is hosting the world wide web is comes in web hosting. Now, there are essentially three main types of hosting if you want to categorize it on the basis of purpose, and also the usability of the hosting provider that you are using. The first one is a shared hosting, which is very common. Most of the website in the world, like the self-hosted website, are done using shared hosting. So if you're going on GoDaddy or you are going on Big Rock to host your website, that is utilizing the power of shared hosting. Now, what shared hosting means is, like, for example, let's say you have a laptop and you have your five siblings who want to use the same laptop. So everybody will have a separate C drive, D drive, E drive. Everybody will have a separate kind of folder to use, but they will be utilizing the same hardware capability as you. They won't be given any special RAM, or they won't be given any special hard disk. They will be utilizing and sharing the same resources. That is what shared hosting stands for. And it's most common, like it's very cheap, it's very low maintenance. If you have your personal blog, if you are hosting it on something like a Netlify or Heroku or even GitHub Pages, all these are example of shared hosting. It's very cheap, sometimes it's even free. But the next one is called a dedicated hosting. Now you want to buy your own gaming laptop that should do things like smoothly and possibly. You want to be the James Bond of web development, and you don't want to share your resources. That is where you want to get the dedicated hosting, guys. And it's the speciality is that you can choose your own GPU, CPU, RAM, whatever you want. And it's actually a physical server. It's like your laptop, but it is in a data center. That's the place that is called that, where you host servers. And they provide the electricity, do the cooling, and all these things run very hot. By the way, data centers are the biggest consumer of electricity today, power consumer of electricity. So whatever is you are saying, cloud is basically the biggest reason of maybe you can say global warming, but you can't do anything about it. The only thing you can do is to create optimized applications so that there is less server load. So the next, but there are few problems with dedicated hosting also. Let me explain all of these three things, and then we'll go to each of the pros and cons. The next one is VPS hosting, which is also known as virtual private server. Now this is a synonym for cloud. So if you hear somewhere called something called as VM or virtual private server or cloud, these are all these three things, three same things. I got this diagram and they were not labeling it as cloud. So cloud is more fancy term, because VPS is like, oh my god, like VPS, I don't know, it's an old word, but cloud is like fascinating. Somebody can go and give a cloud course, but not a VPS course, right? So that is what VPS hosting means. And the difference between the server, your dedicated hosting, and a VPS hosting is basically in your dedicated hosting, you are managing everything on your own. Like you are not able to scale. If you want to scale, you have to manually add all these servers. If you want to add increase the hard disk or RAM, you have to shut down the server and add this. But VPS hosting is little different. What they do is basically they create a whole cluster of machines which works together as a single entity, as a single unit. And then they create multiple virtual machines on top of this infrastructure. And then you can choose any virtual machine which act like a same like a dedicated hosting, but on a much scalable infrastructure where your website is hosting. It might be confusing for you right now, but just to understand the difference between these three, this definition is enough. And we'll go through pros and cons, and we'll understand how cloud works and what cloud basically is in the upcoming slides. Now, which hosting is right for you? Frankly speaking, if you are just a beginner in developing websites or just creating your old school blog or website, you don't need to go to these dedicated hosting or VPS cloud at all. That is where shared hosting comes, because the price is amazing. If you can see 5 stars for price, simplicity, it's really simple. You don't you in just a couple of clicks you can copy and paste your folder and your website is ready to go. But on the downside, you don't have dedicated resources. You are sharing the resources from somewhere else. So I mean, the speed of the website won't be that much, but you don't need that much speed anyways right now. And also it's difficult to scale. If your website is being used by millions of people like Google search engine or YouTube, on which you are watching the video right now, so it is going to be difficult to use the shared hosting for that. That is where like the old people were used to use their dedicated hosting, like when Facebook servers or YouTube servers existed in their own era. So they used to have dedicated hosting. The VPS cloud thing didn't came by that time. And the good point is resources is totally yours, but is fucking like really expensive. You are spending a lot of money on electricity, on training people. You should know networking a lot. You should know how internet works and all these things, which makes the whole process really pricey. And also the simplicity is little less. But and also there is another downside, that for scalability you have to shut down the machine, add more hardware, then shut it on again. And to kind of overcome all these challenges, then it is where VPS cloud came upon. So if you are a person who wants both the power of flexibility at a lower price than dedicated hosting. This is where the cloud things comes in. Now you might feel like, okay, there are many problems like the price solution, and for that you have one solution, like this guy who just want to get rid of all these things, like me, you don't want to, like, I don't know if this theme is even appropriate, but it made me laugh, so I thought of putting it here. So you have five cloud problems and one solution, that is learning cloud, and that is what we are going to do today. So if you ask your grandma and you tell what cloud computing is, she'll probably say that, oh, now computers can really fly. But that's not. Let's demystify the cloud thing that's happening today. So basically, this is a very good diagram in order to understand how cloud is basically hosting the application, if you are interested in knowing that thing. So the technical definition this diagram says, let me read it out. Cloud hosting is a server and network infrastructure that uses software to divide a single physical layer into multiple virtual servers. Arthat, you have a common infrastructure which is combined together, right? You have like multiple vehicles, and you have clubbed up the multiple vehicles to create a single monster truck, and now everybody can have their own seat and utilize the whole infrastructure as per their will. That is what we are doing. So you have a single physical server on the top, then everybody is divided and running its own VMs, virtual machines, which are like a virtual way of kind of dividing the whole physical space. And each virtual server has its own dedicated resources, like something that you can use for application development, something you can use to host your web application, and also you need to have a remote accessible desktop, like how you use TeamViewer, or what was the else, AnyDesk or something, to access remotely your machine. This is the same way how you will access your virtual server in your system. Most of you have tried VirtualBox, Oracle VM VirtualBox. This is exactly the same concept, in that you can imagine the cloud to be your machine, and the VirtualBox is providing a virtual machine to another OS in which you are running your Ubuntu or whatever virtual machine you tried to explore at that time. But on a cloud level, which we say for AWS or GCP, this is happening on a very large scale, where all these data centers, let it be like Kolkata or Mumbai or Singapore or Dallas, wherever your server is, it is acting as a single machine, and then they are dividing them into chunk of different small unit called as virtual servers, and every server has its own dedicated application development, web hosting, remote accessible desktop. If you're not still clear, no problem. By the time we are going to end this presentation, you will be clear with most of the things that you should know. Now, let's get into some of the most important thing that I think you should know about cloud. There are a lot of terms like when they talk about cloud, but we are going to talk about what are the most important terms that you should know before you can appear in an interview, and then you can learn more about these terms. But here is kind of a menu card for this thing. So the first thing is access management and control, and it's same like you can choose to let things go in the fly, but most of the people like things getting controlled and like handled in a very good fashion, and that's not Babu Bhaiya style. So we are going to learn about a little bit about what access management and control means. This is the first level of cloud infrastructure. So imagine this as simple as logging into your Windows machine or whichever machines you are right now logging into. And there is a dedicated support system in every cloud provider that is called IAM, Identity Access Management. What identity access management does is it provides every user, whether it's your employee or different cloud services or something, a safe way, a safe access to go and check the cloud resources. Actually, you are trying to, you're doing, it's doing the same job as how TeamViewer is giving the pin code in order to get logged in to the other side. That's the same thing that we are doing here. So most probably we use SSH keys most of the time. So SSH keys is a way to like interact with the server, same as how a physical key works. Every key has its own signature and it's very unique and encrypted, so it's very impossible kind of thing to get logged in. And the passphrase, the normal passphrase that you use in your laptop, 1234, doesn't works in server in that way, so you need a SSH key to get logged in. And then every cloud provider also provides the capability to divide the different responsibility on different levels. So if you have multiple people, some of them doesn't needs to go and use machine learning resources, or just needs to use storage. They can use certain resources, and you can tie up these things in access management and control. So when we'll explore the cloud system, I'll show you how this thing works, how you can add multiple people, how you can create groups, and how you can actually divide roles so that multiple people use different resources. Now the next important thing is network. You have your machine. This was a common question in my mind when in the beginning I learned about cloud, that why not we host the website on my laptop. I mean, it's working fine on local machine, and I my machine has an IP address, so why not someone from other part of world can access my website on my laptop, right? You might have the same question. But turns out there is a lot of different things involved in order to make sure that a website named as www. Uh, gdg.community.dev, whatever the website it involved, involved in, make sure that this website lands to the same servers every time. That's a complete science altogether, which has taken a lot of time. So Bhavnur has a question: what does SSH stands for? So I have an upcoming slide where I'll be specifically talking about SSH and what it does and what it stands for, so bear with me. So uh, what the fundamental question about network in a cloud infrastructure is that every machine on which your code is hosted on is identified by a IP address. IP address is same like how your phone number works. So every machine has its own internet protocol address, which is in this format 192.0.2.44. It can be in another formats also. There are various complex formats, but for this example, let's say it's this one. So actually, the machine is identified by IP address. But when you are going on some internet website, you are saying it to be a google.com or abc.com, right? So how it is translating that into that format is same as how your phone stores contact on phone books. So you have some kind of phone memory in which every name corresponds to some kind of phone number. In the same fashion, you have something called as DNS resolver. DNS stands for domain name resolution, and this is actually used to store the name of like the corresponding IP address to every domain. So let's say you are going to example.com to get this picture of Mona Lisa from your laptop. Now this website is actually hosted on this server, but when you go to this website, you don't know actually what IP address of this machine is. So basically, the request firstly goes to DNS resolver, and then you go to TLD. TLD, I don't know the definition of this, and you don't need to know either. But I at least know that TLD is has to do something with this .com or the last extension. So .in, .com, .gov, .org are the first resolution. That is how different domain names are grouped. So this is the first thing that you will get from the DNS root name server manager, and then you will get a certificate from the TLD manager, and then you will get the actual IP address from something, a service which stores the address. Usually in AWS they called it route 53. I think in Google Cloud it's called the network protocol. Oh my god, I skipped it. So you, after you get the IP address from any of this server, DNS resolver gives it back to the end user, and then the end user goes and checks for the website. Now there is a very handy way to actually try out if what I am saying is true or not. So basically what I'll do is I'll open command prompt on my system, and what we'll do a small ping of google.com. Okay, so you see that I have actually typed google.com, and it actually responds to this kind of address. This would look a little different than IP address because this is an IPv6 address, which is a new format. It's good to see that now you will be using IPv6, which is a much more vibrant format to use. And even if you want to see how this request went to google.com, you can use this command trace rt. So now you can see one by one we are going through different services, and this is actually reverse tracking the whole request to the actual server. and this is how we are translating each servers to reach to the actual machine. Only the first hop is responsible for getting the actual machine address, and after that everything is just magic. It just flows like how somebody is telling directions to someone who is new to a city. That's how the global internet works, and this happens within 1 second. Like as soon as you hit google.com, everything appears. Right now we are tracing the route, that's why it takes time, but this is how it happens. If you are not able to see the screen, that could be a good issue, but I don't know how. Okay, yeah. So you can say when I have typed traceroute.google.com, it goes to this IPv6 address and then hops over to different servers to reach to the actual destination where the actual server lies. So this everything is kind of categorized in networking, and whenever you're hosting your application, web application, which needs a certain IP address, you need to know a little bit about network. Again, I won't go in detail. There are different network names like CNAME, A address, AAA address. CNAME is canonical address and A is normally address, and TXT record. All these things are used in order to verify and make sure that the right domain reaches the right server. To know more about this, again, I think you can check out the crash course that we did on mobile web dev, and I explained pretty much what each record means, and you need to just know this in order to like get your website running on the cloud. Now you see this meme, and this is actually on this purpose, like everybody hates slow internet connection, but sometimes you would feel like, right, like you have fast 4G but still things are not loading in the right manner. It's probably because the server on which the actual file that you are trying to download that is hosted is really far away from your country. Let's say you live in this part of Russia, I don't know what it is called, and your server is actually located somewhere in Brazil. So even though all these things are connected using fiber optic cable, which means that data is traveling on the speed of light, but still when the data hops through congestions and everything, it takes a little bit of time to get the request get from here to your actual server. Now I know Earth is round and it can take a shorter route. I'm that smart too, but I'm just like explaining in for a hypothetical purpose. So instead of doing that, somebody was very smart and he thought like, why not store one copy of that file locally near to your server, and that's where CDN was born. CDN stands for Content Delivery Network. What it basically does is it's stores the copy of files that a person is trying to access on different location around the world, so that everything is closer to you. Now, for example, if you are located somewhere in this part of China, and this is your actual server, which is somewhere near California. And what this will do, instead of you making the request directly go to California, you are actually going to check it from a local server, which is a CDN server, which has already cached a copy of the actual file from the actual server and stored a copy of the file on its CDN server. And that's how it is getting all these files. This is very much used by kind of everyone today, mostly Netflix. Whenever you hit on the play button on the remote, your website like movie loads so fast. So what Netflix is actually doing is basically it's using AWS infrastructure to store the copy of movies in the local areas of your location, so that the data doesn't takes too much of time to travel. Why it is important to understand when you're doing cloud is basically at some point you will be creating an application where you need to add a high speed resilient thing, and there's where you need to know CDN. There is not a lot of things that you need to do in order to set up your own CDN. The CDN automatically does most of the things on its own. It's just a layer between your actual server and the client. So it's basically a buffer which is taking the data between to and fro's. Now, cloud storage. You like if I know you are much smarter than me, but I was this dumb that I thought like cloud storage basically when you are storing everything on cloud. I don't know how they are floating away, but that's not actually what cloud is. Basically, cloud storage is little different than cloud computing. Cloud computing is more on the power side, but cloud storage is basically just storing all your documents somewhere on the cloud so that it's very easily accessible. Cloud storage utilizes the full potential of CDN that we just talked about in the previous slide. So you are able to store your photos, files, document, music, videos, contact, anything that is static. If you are storing anything on Google Photos, or something on Google Drive, or like even this presentation that is running, it doesn't require any computation to work. It's kind of a static file, how some movies and some photos remains like on your Google on your hard disk. It's same like your hard disk just running on the cloud, and this is relatively cheaper than using cloud computation. So a classic example of cloud storage is like when you go on cloud, it's S3 with AWS and Google Cloud Storage for Google Cloud, and this is like a static way of hosting all these files and things that you want to store. Then finally, databases. This you might already know if you are creating some full stack applications, but this is also part of cloud, because as databases also need a computation, and it also need distributed infrastructure that should run very smoothly. So all these services that you see can be hosted on the cloud also, to give you minimum time on maximum latency. And we'll see about what are the different service provider for databases. Popular database providers are like MongoDB, which I have used recently. They have a cloud database infrastructure called as Atlas. And then you have Amazon Redshift, which is a data warehouse technology where they store all the database on their infrastructure, and they manage everything from scaling to managing everything. Google BigQuery is a, they call it NoSQL, but basically you can run SQL commands in Google BigQuery. And MySQL is the traditional old school but widely used, most popular and reliable. So all these are different kind of databases. It's an organized way of storing collected data like registers or records. You might understand databases by now. Next is the most important part of cloud, for which we actually went to cloud, because all of these things can be easily done on any kind of storage. But the compute or virtual machine, that it's generally termed as, was the main reason of moving to something as a cloud. So cloud computing is a basically a capability on demand running computer systems on their resources, on their storage, at any time of the day or night, whenever you want. You have, you click on button, and then you have somebody running PC behind you, like all the infrastructure and curtains, and making sure you have a optimized performance without you actually investing for the whole machine. That is what compute means. And this is the building block, the fundamental building block for everything that cloud stands for. So basically all the infrastructure that we discussed in the previous slides, in which you have a collective infrastructure of data, and then everything is kind of divided as a virtual machine. You are getting a slice of this virtual machine and then running your application. You can of course specify how much RAM you want, how much processor you want, how much hard disk you want, that is connected with your virtual machine. And this is actually where your code or application, whether it is Python, PHP, JavaScript, Node.js, basically runs on a server. This is the actual hardware that is used in the compute. Now there is a new terminology that have been coming recently, and I thought I would touch a little bit about this also, which are called containers. Now basically the one of the drawback in using raw compute or raw VM is that whenever something happens on scalability issues, you have to manually create a new uh, kind of server, or increase the RAM of the server, which kind of can have some downtimes, and it won't happen so smoothly. So container is a new logic which I really liked. It's same like how you can create an ISO image of a VM, and then you give the ISO image to something like a virtual box, or you can even install on the system, and the system automatically understand everything, how much D drive, C drive, or how much dependency, what software you need. So it's basically a virtual copy of everything. It's kind of backup of everything that you created. And then all the container application system like Docker or Kubernetes understand this image file, and then it expands and scales the application automatically on the infrastructure without you deciding what RAM or what computation you need. So it automatically kind of run your application on the cruise control. You just need to create the code, create a copy of the image, and then launches on the cloud infrastructure, and Docker or Kubernetes will take care about that on its own. Now this is not like a this is a short definition, I mean. And there is a huge part of ocean that you have to learn about Docker and containers and Kubernetes. So make sure, if you want to create application on a scalable format, you want to know this thing, then you need Docker. But if you are creating normal applications, then just learning normal compute and everything that I told ahead was fine. But it's good to learn this technology also. Now we have talked about everything, and this was like all the cloud discussion, hawa mein baatein, and everything we were doing was just in a definition format for you to understand how things works. Now we'll talk about actual controls, how you can take control of this whole cloud infrastructure, how you can create your own VM and everything. So that is where the method of controls comes in. And there are two ways by which we can do controls. One is called FTP, file transmission protocol, and SSH. Both of these have different functions and purposes. So let's discuss each one of them at each time. So first one is called FTP, file transfer protocol, and it's different than internet protocol. In internet you are actually serving web pages, but in file transfer protocol you are actually serving files. So basically file transfer protocol is the process of transferring your files, your code, your data, your repository from your local machine or any machine to server. That is where you need to use file transmission protocol. If you have any code that is going from GitHub or anything, it would underlay the principle that it will use to transfer the file will be the file transfer protocol. Okay, and there are various application that I can show you. I was using FileZilla earlier, which I don't have anymore. Now these days I use Termius. So basically Termius has a property for file transmission protocol. By the way, if you are a student right now and you have GitHub Student Access, this application comes in bundle with GitHub Student Access, the package, and I am still using this one. I loved it, and it's a very easy way of connecting with the server. So basically what I do is I go to the SFTP section of this application. SFTP stands for Safe File Transmission Protocol, which is a safer way of connecting with your server. And then I select my host where I have different servers that I have been using. This is my local machine on the left side. This is the actual machine, the server on the right side. So let's say if I want to go to this, I have nicknamed this computer as dash.twimbit.ai, which is one of the AI project that Twimbit is doing right now. So when I go on this, I can see a virtual, this is kind of a virtual connection between the server, and this is all the files and folders just like your machine but on the server ready. So the way I'm communicating with this right now is through FTP. And if I go back, and now I just forgot in which directory I was in. So basically I hit the back button. This is the folder that we are using to work on. And if I have a file or something like in D drive, let's go and see if I have something spare. So I can just put up this PHP file, which is a wp-config.php file. I can just drag and drop, and now you see it is transferred. So this is as easy as going and getting connected with FTP. But this is a already set up connection, and let me show you what how you have to set up if you are just a new person. So if you go to an application like Termius, so you have an capability to go to new host, and then you have all this information that we were talking about, the address of the machine, the IP address as we discussed in our previous one. Then you have to select a port. There are various port. This is also provided by the server, and you have to just add the port. Then you have to add the username. If you are running Ubuntu on the server, then you just need to add Ubuntu. You can add the password if you are using password protection, but if you are using SSH key, which is the standard way of using it, then you can import your own key, which is generated by a cloud service provider when you are creating the machine. And you have to keep this safe, and when you create a primary key or SSH key, you just need to store it on your system and then upload the key in here. Once you do this, you have all the access, and then you're ready to go. Now I can't show the details of any of these server because these are live servers and confidential, but this is easy as it gets, and that's how it is done. Now the next way to do this was to transfer files. Now you actually want to run some kind of command. So these basically I have already explained this. Let's go through this diagram once more. This is basically the steps that are involved in order to make sure that FTP steps happens. So this is the client, that is your local machine, and this is the server, and this is the transmission control protocol or IP protocol, internet protocol, which is making sure that the connection happens. This is the user interface of the FTP application, in this case Termius. And then you have control process, which is kind of connecting things on the both side, connecting the disk to the data transfer processor on both of these side, and then the data sharing is taking place, everything that I just told you. Now the next one is called SSH, which some of one of you actually asked what SSH is. So basically secure shell host, and this is the main way of how you can connect with the server. So the previous one was to transfer files, but this is how you can run commands. So basically the SFTP one that we were using on the underlying principle, it also uses SSH, and then it is writing the commands for you, all the CM, MV, CP, all the commands for copying files from local machine to the actual machines. Underlying, it's using the same principle. And this is the SFTP, which is a subsystem of secure shell protocol that I was explaining to you. And FTP is just that, just without any SSH keys, you can just use the password to connect with the server. Now, this is the general definition. I will share the slides with you if you want to go through the theory, but I can show you directly a practical of how these things is done. So basically, if I go to host and if I click on any of the server, then what it does is basically it is kind of making sure that I have the right access, and then I get into all this terminal. Let me try to zoom this for you so that you can see things clearly. And what it is doing, you will see this is kind of familiar as how your local machine looks like, and this is how you actually run all your commands and everything. So let's run a simple ls command. And ls command actually helps us to see the directory list, and you can see it has listed all the files that we were seeing when we were in the FTP mode. And all these files, just like how you run your Ubuntu commands and everything, are displayed over here. Now this is currently a running server. So there is a command that is used, I think tmux ls. Okay, so you can see I have a window of application running, so I can just start a application over here, which is a Python project, and keep it running, the all the Python commands and everything. And if I have to go and see this one, this is not part of the course, so I think the command is tmux t attach. All right, I think we should be after attach. Okay, so now I'm kind of virtually connected in the same session, and my application is kind of running all the time. This is all the error logs that are occurring, but I am not kind of seeing all these things all the time. The server is just running it in the background, and to initiate the process, I have to use the SSH thing that we were doing. So this is another demystification. Now, some of the people are very confused. Aman, like, okay, I have created the app, but how I actually start the app on the server? This is the way to do it. Just how you do it on the local server, but instead you are connecting on the cloud and or the server that on which the application is running in order to run this thing. We'll leave this thing running right now, and because we will, I think, go through another demo of what things look like. And this is how actually SSH architecture works. So basically, client and server has a key, which is basically how a normal door lock key works. So there is a kind of a negative pattern of all the key that you have, and the private key is stored on the server, and you have the public key. The key that we were uploading in the SFTP software, in this case Termius, is the public key. So when you want to connect, you actually share the copy of the key through the SSH connection to the server, and the server actually tries to match if this is the actual key that the user has intended to do that. And also it gives the private key in back and also matches it with the user account. So there is a handshaking happening both on the user ends, on the server ends. And if these things works fine, then a session is established, and then you are able to connect virtually on that side. Same like how somebody accepts calls or something like which involves a mutual permission, that's things involved. Now this is all the theory part and everything that we discussed. Look, now let's come to the actual work, where the actual cloud is. So there are too many options to choose for basically, and I was very confused why you need so many companies. Which cloud service is better, AWS cloud, Microsoft Azure? We'll cover this question, Samarjeet, after just this slide, because this is where I will talk about that main question. And we'll see what cloud you need to choose. And there are many options, right? So we'll go through each one of them, and all the services that I told you in the first present like slide, I will try to kind of translate them of what service is called in what cloud provider. So basically you have to understand this thing. The underlying principle of cloud infrastructure that is provided by all service provider is kind of same. So it's just the packaging, they are packaging things differently. Same as how slides are called Google Slides in Google, in G Suite, and how it is called PowerPoint in Microsoft. Same is the case with Google Cloud, like, or AWS services, and they are almost the same and all the canonical names. चीज सेम है but नाम अलग अलग है. That's the thing that they are actually doing. So the main part is the compute part, right? The compute thing, that is what we studied in the first part, right? So that is where your this thing comes in, that is app engine, cloud pub sub, transfer appliance, which is more kind of it all has all the features and everything, just not the bare minimal that you need. It's like kind of already configured kind of instances, like Maggie cooking noodles or something. And then you have storage, which we also discussed, cloud storage. You have different forms of storage, cloud big table, cloud data store. SQL is again for databases, cloud memory store, BigQuery, cloud spanner. This is basically for storage and databases. Then you have some processing and analyzing tool, which is different for different cloud providers for different purposes. And then you have exploring and visualization tools. Same thing is with AWS also. They have application server. The most popular service by AWS is called EC2, which is Elastic Compute. I don't know what the other C stands for, right? But why we don't need to know. But EC2 is basically for computation. And Amazon's most popular service is AC2. I think it's even cheaper than Google Cloud Compute. And that is what is used for computation. And then they also have introduced something called as AWS Lambda, which is a serverless computation format. Then the CDN that we were talking is part of storage and content delivery network. Then you have databases, networking solution, Route 53, VPC, all these networking solution, different analytics tool, same as how Google have exploring and visualization tool, they also have analytics tool. Then deployment and management, same CI/CD tools that Google also provides. Administration and security, IAM, identity management, that I explained you in the starting. Mobile services, application services. So basically anything you want to work on, you just need to define what you want, and then there is a service already set up for you, which is relatively easy to deploy, and you don't need to do a scratch thing from us. Then you have something called as DigitalOcean, that is also the, I think, which does Hacktoberfest and everything. The one thing that I like about DigitalOcean, which they also brag about a lot, is the simplicity that they say. And it's actually very simple. If you are just a beginner, it's very easy to understand. So they don't have any fancy names or anything. So they simply have categorized all these services into compute, storage, networking, databases, and developer tools. Right? It's so simple. Why you need to call them EC2, Cloud Spanner, and Big SQL? But so they were very smart on doing that. So on compute side, they the equivalent of EC2 or the server is actually called a droplet. This is what they call a droplet. And then Kubernetes is again something to run your containers on. And then app platform is basically to run your app, which is a serverless way, same as AWS Lambda and same as Google App Engine. That is what is called app platform in compute. Then you have same as S3 storage in AWS, you have something called as Spaces object storage, which uses Spaces API to store normal files like photos, videos, things like that, which doesn't require computation. Then you have databases, MySQL, PostgreSQL, and Redis. Redis is a new format of SQL. I haven't tried it yet, but that's something I have to do with that. Then in networking, you have DNS, domain name solution, floating IPs, all these VPC cloud again to connect your server to the domain name that you want to do, and then developer tools like API, CLI, and everything. Again on it, Azure, same thing, same story. I'll try to kind of translate all these things, all these services in this format. So you have cloud services, which comes in the compute. They have named it into web apps, service fabric, API apps, API management, logic apps. I haven't tried any of those, just cloud services and API apps, right? And web apps also, which has ready-made apps like WordPress or Django. You want to run them, they have a managed solution. Then developer service, just like a CLI, Visual Studios, you might be using already. Azure SDK, Team Project, I haven't used them. Integration, then you have analytics and IoT, same that Google and all these things are providing. Then for data, you have SQL and NoSQL, which is I don't know. So document DB, I think, is a NoSQL format. And then again for media CDN, they also have a CDN service, just content delivery network and media services. So you can say kind of it's almost the same thing other. And now it comes to the final question, like, which is better? Actually nothing is better. And until unless you are on a position like on my position, where you have to decide for the whole company, this actually doesn't bother you at all. And if you are thinking of what cloud you should actually learn, I would prefer to actually, yes, this is same like how you learn data structures, or how you learn normal algorithms and everything, and then you can easily switch to any programming language. If you learn it from C++, you can easily switch to Python. You just need to know the syntax. The same story goes with cloud providers also. The basic thing that you have to know is how to use CLI, SSH, and FTP on a server. If you know all these things, you know how to run on Ubuntu. Everything is hosted on Linux. Everything is being used by that. And then rest of the things are just based on documentation. You just follow step-by-step guide that all cloud providers provide, and you connect everything together on your own. So I would prefer how actually I learned cloud was basically I knew CLI and Ubuntu a little bit in my time, and then I started creating and hosting application on AWS, because AWS comes free. You don't need to put any credit card or anything. DigitalOcean also has free. If you have GitHub student access, you can get DigitalOcean for free. So try to host your website, your blog on DigitalOcean, and they have, many people have written a lot of documents and everything that can help you get started. So just start with one, and trust me, when you deploy a full stack application, I mean full stack which has a back end, a front end, a database, and something with identity management, once you do everything this together, you will understand what goes ins and outs in one cloud provider. And once you do this with one, for example DigitalOcean, then you will be easily able to do it with any provider, let it be Google Cloud or AWS or Azure. I have started with EC2, which is AWS service, and now I can probably run anything on any of the cloud infrastructure now. Even the latest one that are coming, that are not even out yet, I can run these things on them also. It is basically just the UI. So you need to know how to sing, and then the studio is like just a add-on. So this is what actually it means. You need to know driving, and then it doesn't matter which car it is. You should just be flexible with anything. In your resume you should at least list one, but having more than one is also fine. So now let's play a little bit with cloud. I have already showed you a little bit of techniques on how to connect with CLI and SSH. We are almost on time, so I'll try to do this pretty quickly. If you have any questions so far, make sure to ask them so that we don't leave all the questions in behind. And this is just a playing field that I'll be showing a little bit of things with you. So I have planned to use a small technique, which is actually like a game. So what is the roadmap for cloud engineer? Very good question, Samarjit. So basically, I would say you start with something on the basis of CLI. You learn Ubuntu and everything. Like, I don't know, you are talking about certification. I'm just talking if you are asking this for learning purposes. So basically, you start with Ubuntu Linux CLI command line interface, and then you move to a host application on one of the servers, and then you learn one of the server technology, deploy a full stack application on one of the servers, and then finally you move to other service providers. So this is how the cloud engineer things goes on. But the technical definition of cloud engineer is someone who actually does all this networking and programming. If you're an application developer, then you don't need to know the ins and outs of networking, the detailed thing that we are talking about. Many different kind of cloud providers like GCP and AWS have different certification program, I guess. Like AWS has certified cloud architect, GCP has a GCP cloud architect, all these certification that they are doing. So it contains all the syllabus. It's not that hard actually. If you just want to start with, you can just start today. I think right now uh, DSC is doing something GCP learning program. You should do that, and you will also kind of earn some T-shirts. I just got to know about that from a social media post. So this is a very good way of learning a cloud technology. Now you know the fundamentals. You know what was the bottlenecks. So maybe this will help you get easy. What I will do now is I will try to play a small 30 days of Google Cloud, and this is a small game where we will try to create a sample architecture for your Jamstack application. How does it sounds like? Do you want to raise some comments if you have any question or a suggestion of what kind of cloud stack that I should create? So the basically the activity, the game purpose is, if you want to kind of translate how Netflix works, how Facebook works, I'll try to replicate the same thing in terms of cloud infrastructure. So I'll draw a diagram of how everything is connected so that I can explain uh, how these things is working. Maybe I should turn on the comments. Yeah. So maybe you can suggest me some examples of what kind of cloud infrastructure you would like to see, what kind of application. Till then, let me have a sip of water. Okay, all right. Just to like take care of the time, I'll be deciding on my own. So let's kind of create a normal full stack application that has a front end and a back end. So the first thing that we need is a computation machine for our front end. So this is what we'll keep. Like this is just the bare minimal. We are just starting our startup and we don't know a lot about cloud and everything. So this will be a very easy way of starting that. Now the thing that you see over here, M4, is the type of machine that we are choosing. Basically it's on different basis what kind of processor you need. Right now this M4 is using 2.4 gigahertz Xeon processor, 2 CPU cores and 8 GB RAM, which is kind of a lot. I don't need this much. I would just go with let's go with T2. So it has 3.3 gigahertz processor, 2 CPUs, 8 GB RAM, which is again the same. Let me go with the simple one, maybe A1. Okay, yeah, 2.3 gigahertz ARM processor, 2 CPUs, 4 GB RAM. This is what I need for my front end. Now, another thing that I need, this front end will be somehow talking with another CPU, which is the back end of my application. So let us also, this will need a little bit of more CPU. So I will just add another, which is 3.1 gigahertz, 8 GB RAM. This sounds perfect. So basically this is just a trial and error. This is not the exact way we do planning of things, but I'm just trying to show you how things work. So this is, I don't know if, okay, yeah. So the request is going to the backend, and then this application is basically a full stack application, so it will be using a database also. Let's add a database which is a NoSQL database. Let's do a NoSQL database for this one. So this is a NoSQL database for our application, and our backend actually needs the database. The front end doesn't need the application. So the request is going to the front end, and then the database is also responding with the request. So these are talking with each other, and then when the request is getting approved, this is sending back the request to one. This is our architecture, but this is fine if we are just using IP addresses to run our application. But this is not actually what we want. We actually want to host our application on something such as joomla.com or something like that. So what we actually need is some route 53 at first, because you guys now know that route 53 is used to route the traffic from incoming person to anyone in the world. So this is the route 53 that we'll use over here, and then let us this be our user. Can we change the user? Yes. What is more user here? User. Yeah. Let this doctor be the application user over here. He's like, we are creating a COVID-19 application, let's say. So this person is going and going on COVID-19 joomla.com, and then this route 53 is trying to suggest where this application is actually hosted. Let's move it a little bit over here. But this person can come from any place in the world. So what we need is a CDN in between, as I told you. And in this case, that will be our CloudFront. So what this CDN will do, it will store a copy of all these files that we are asking it to fetch. And then this request is going to the CDN from route 53, and the CDN is then transferring the request to this. Now, this sounds, I think, quite good, and this will be then sending back the response to the CDN service. And yeah, so the CDN is kind of using and caching all this application on the back end and front end. And now the next thing that we need, sometime you will be hosting some static files also, right? So you need something like a simple storage, the cloud storage that we were talking about. This basket represents the cloud storage. and sometimes our front end application will be talking with our back end, sorry, the storage, and sometime, yeah, okay. So this is our cloud bucket. Sometimes the backend also needs to store some things, and okay, not the smoothest one. Yeah. So our bucket, the backend is storing some files on the bucket, and then sometimes the front end is accessing the files on the bucket, and sometimes maybe the user might be directly downloading all these files. So this CDN can also fetch these files directly. Now I probably have a little bit of experience of how these things works. That is why I can guess how things are connecting with each other. And this is now our full scale application. If you want to see them in 2D also, this is the 2D way of doing it. And I don't know if there is a application. I'm using Cloudcraft right now, and there is a similar, I don't know if there is a similar application for Google Cloud, but this is good for planning application and everything. And once you are doing this, then you can just go to the budget and see how much it will cost. So see, our application will only cost $100 per month. That's not that expensive. And this also explains what kind of cost it's contributing to. Most of this cost is done by EC2, and maybe we don't need that much kind of CPU, and we can go over here and just reduce it, now. Oh, actually, you know what, we just need a T2, and the size should be micro for the front end. You see, now it is even more cheaper. So if we go to the budget, now our budget is just 78 per month. And maybe if your application doesn't require that much of backend, you can reduce this one also. So this is how we play with the cloud, and this is how you create a cloud infrastructure. And then to establish a connection with everyone, so you will connect with the this one SSH and this with SSH, upload your files, run the code, connect everything together, and then your application will start working. This is just an overview of how things works. So let's wrap up things pretty quickly, and let's see some of the common architectures of application. So this is how you can use web apps. As I explained you are using route 53 to resolve the application address. Then the CDN is using it to route the traffic from the S3. And then you have the front end, which is using again auto scaling. This is something for a big web application. You have also installed a elastic load balancer, which kind of balance the loads. And then this is how it is making a request to the backend, which is also having auto scaling. And then you have a database service, which is RDS master. This is kind of almost the similar as our application, but our application doesn't require that many of servers and that many of redundancy. So this is just a simple architecture. This is another application on how you can run web apps on Google Cloud platform. So let it be your any device which is native app or web app. You can host the front end of the application on Firebase, which is almost free. And then the back end of the application can run on serverless architecture such as backend app engine. It's not actually serverless, but it's a managed server resource, which you don't need to specify the CPU and RAM over here. And then you have other applications like cloud endpoints, a load balancer. This is a normal architecture look how you will create a web app on Google Cloud platform. So with this also, with each individual service, you can connect with SSH. And this is an architecture of how you can create a high availability setup. What high availability means, that if in a rare chance of failing of a server, how your traffic is automatically routed to another server, so that there is no lag for the person. So again, a person is coming to example.com, which is resonating to this IP address, and firstly the request was going through this one, and there was a health checker that was seeing if this thing is working properly or not, which failed for some reasons. Then other one automatically got active, and the load balancer automatically routed the traffic between app server 1, app server 2, and on the back end they again have a database which is replicating its record. So this is kind of a high level availability service. If you want to create something like a police application which never needs to fail, this is the architecture that you're looking at. This is something for machine learning guys, if you want to understand how machine learning works on cloud. So if you want to host something like a TensorFlow application using GPUs on Google Cloud platform, so this is our user. Then we have installed a load balancer, and then we have created two zones. Zone A, which is hosted in some other part of the world, and then zone B, which is located in some other part of the world, depending upon where your application is hosted. Then every zone has an instance, which is actually the Google Compute, and you have chosen what kind of GPU you need. You have chosen this GPU, and then it is connecting with Stack Driver. Stack Driver is basically a serverless way of like running all these things on Google Cloud. And then you have pre-trained models on normal Google Cloud storage, which are served on both of these machines, on machine A also and machine B also. This is again a small kind of thing that how cloud architecture actually looks like and how it works. Now, this was a kind of a demystification of how things in cloud works, and now it is the actual final part of what you have to learn next in order to master more of the cloud skills. So the first thing, you need to know about the fundamental working of each of the provider, Google Cloud or GCP or AWS. Just learn the fundamentals. Then you need to know about the CLI, how to run Ubuntu command, Linux command. If you're using Windows Server, how to run command prompt. Then you need to learn a little bit about planning, how you can plan a different architecture of the applications. For example, how I was just doing guesswork. For this, what I actually do is read a lot of blogs, read a lot of videos, see example architecture of how different application works, and then I try to replicate these things on my own applications. Then you need to learn a little bit about environments and how you can set up things, how you can set up your own servers, and how you can set up your own machine. Then you have to learn how you have to deploy your application, which involves learning a little bit of CI/CD, GitHub Actions, code testing, automatically code deployment, and then at the end you have to learn how you can use containers, and then at last how you can manage and maintain your servers for updates, for firewalls, of all these things. So these are all the things that you should know in cloud. And with this, just remember, there is no cloud in actual, it's just somebody's else computer, and we are just using part of it. This was Aman Sharma, and I hope you enjoyed the session. I was able to deliver something valuable today. If you have any questions, please let me know.
Thank you so much, Aman, for such an informative and amazing session. Like it was
Welcome.
quite all from becoming a zero in cloud to a tech in cloud. So if you have any questions, you can ask them or we can wrap up.
So I think for Samarjit, I already answered the question of what is the roadmap to become a cloud engineer, all these things that we did in the last slide. Thank you if you like the session, if I was able to make it simple. And also, Sangeeta, can we share the link to the old course that we did so that these guys can easily uh, learn if they want to learn more about cloud?
Yeah, sure. I'll share the link.
Okay. Yeah, I have shared this link in the private chat. All right. So there is a question: what are the best resources available on internet for learning cloud? So I have shared this one link in you must have just received it in the comments. So this is one way to get started with web hosting and cloud from 0 to 1. This is the course that we did in mobile web dev. And for more resources, I think each provider has a very good education plan, which is very easy. For example, if we want to go to something like Google Cloud Learning, they have something called as quick labs. This is a very good way to get started. You have something going on, competition, something like that going on right now. So they have very good way of delivering things where you can earn badges and all that. This is the best way and the most simplest way to actually learn all these things. If you want to start with AWS also has learning programs. can go to aws.amazon.com. I'm just googling things, and then just to learn all these things are very easy. Thank you everyone if you like the session.
Okay, so I guess we can wrap up with the session.
Sure, if you have any other questions, you can connect me with link on LinkedIn or Twitter. I'll be happy to answer any of your questions. Okay, that's it.
Yeah, so that's it. Okay. Thank you so much.